Hey Probstats kids, this is Dr. Callahan with week 14 Wednesday. How are you guys doing? Go ahead and pause the following question, or pause the video and answer the following 3 questions for your warm-up log. All right, so let's go ahead and take a look at your guided notes for today. You have 2 pages and it looks like this for the first page and this for the second page. So if you don't have this, make sure you grab this from the tray as you sign into class. And we're going to get started today with graph models. A graph model is basically a structure of probability that is oftentimes used in real life situation, mostly in probability theory and statistics. And some of the ones that you can see here are representations of graph models, just like the ones that you have created in class as well. Today, we're going to talk about graph models. Yesterday, we talked about adjacency matrix, and so this is a continuation of that. There is a video I would like you guys to watch. It's right here. You can either type this in or you can go ahead and just YouTube it. And it's just typed in graph models. This is the beginning of the picture of it. So make sure you watch this in 4 minutes. And then answer, how are the Euler's path, circuit, and adjacency matrix connected to graph theory? All right, let's go ahead and get started on your guided notes. So looking at this right here, the goal of today is to take real life picture situation and create a graph to model this real life situation. The rule is that you only use vertices, dots, edges, and lines. And the result is that the only thing that really matters is relationship between the vertices and the edges. So for example, in the very beginning of graph theory, we talked about Königsberg, where Euler actually visited this little Eastern European town and was wondering if it's possible to cross all the bridges without any repeats. So this here represents the map. Next, you have a plan. So what you're thinking of is where are your vertex, where are your edges. So in this situation, if you look at it, your vertex is going to be R, A, and L for the left bank, and then D. And then from there, you look at the different paths. So from A, I can go over 2 and cross to R. In 2 different bridges, I can go from A to here or A to here. So there are 2 different paths, so right there. And then from A to L, I can cross this way or this way. So there are 2 different paths. And then in addition to that, you can also go from R to D. 2 different methods. Here's the first one right here. Here's the second one right there. A can also go to D, and then L also goes over to D. And then from the plan, you take the graph of it, which looks like this. All right, so I'm going to go ahead and have you guys take a look at this part here. This is the Sunnyside neighborhood that we talked about with the Postal Service and also the security guard. Remember, you're only using vertex and edges. Okay, so the first part here is you have your map. Then the security guard is going to be going through each block only once, so 1 pass per street. And then, of course, the mail carrier, both sides of the street for any houses. So this is a representation of the security guard's path. And again, it's 1 block per, each block once. And the mail carrier, both sides of the streets with both houses. So you have 2. So now I'm going to have you guys do is you go ahead and try this. It says, create a model graph. A beautiful river runs through Madison County. There are 4 islands, 11 bridges. Join the islands to both rivers of the bank, the right bank, R, and the left bank, L. So here's your R, here's your L. So let's list the vertex. The vertex are going to be the letters, and those are going to represent the land. So A, B, C, D, R and L. And then the edges are going to represent the bridges. So pause the video, draw the connected path, use dots to represent each of the land. All right, so one thing that you could have drawn is something that looks like this. And let me see if I can go ahead and move this over a little bit. Okay, so looking at this right here, you have A, R, B, D, L, and C. Okay, so we're going to start off with these points here. And then from these points, let's take a look at what is being connected. So from R, from this land, you can go to A in this path. So R goes to A, just how I have it here. R can also go to B, and there are two different paths, two different bridges. So R goes to B here and here. In addition to that, let's see, from B connects to D, but there's only one bridge. So there's one bridge B to D. And then from D, I can also cross to C. So D to C. D can also cross to L. So D to C, D to L. And then from there, I can go to C goes to L, and C can go to L using two different bridge. C goes to L twice. So 1, 2. And then L can go to R, crossing the Washington Bridge. So L goes to R. I can just draw it this way. And then A can also go to C, crossing this bridge. And C can go to L. So C goes to L twice with these two bridges, and which I already did. So C to L twice. And then C also goes to D1. So I did that. And so there you go. This is my path. Your path can look a little bit different depending on where you actually put your letters, but this is kind of what mine looks like. All right, so then I'm gonna have you guys do the same thing over here. Draw a model graph of Avon, which is the Indiana neighborhood. So pause the video and draw your vertices and also your edges. And your graph can look something similar to mine like this. All right, so let's talk about Euler's theorem. The big question, when can you draw the figure without retracing the edges and still end up at your starting point? When can you draw the figures without retracing and end up at a point other than the one you began from? So obviously this one is a circuit. This one is a path. And when can you not draw figures without retracing, which is a neither? So a circuit path covers every edge in the graph at least once and only once. So looking at this one over here, do you think that these graphs have a circuit? Try tracing them with your pencil. Now with this one, let's start off with this one. You can start off with here, okay? You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And looking at this, you ended and started at the same point, C. So this one is a circuit. Now with this one, let's pause the video and give it a try to see if you're able to do that. Well, let's take a look. I can go ahead and start here on E, circle. Oh, now I'm stuck. Okay, so that was a bad start. Let's try one more time. Oh, now I'm stuck again. Let's try a different one. Maybe start on A. Okay, and so I'm again stuck. So in this one, it is a big no, it is not possible. Now let's try this one here. So what I want you guys to do is take the vertex A, C, or A, B, C, D, and E. A, B, C, D, and E. I'm gonna do this in terms in the form of a straight line, and we're gonna go through the path, okay? So as I'm looking at the edges, starting with C, C goes to A. So C goes to A then goes to B. B goes to E. So B goes to E, there we go. And then E goes to A then goes to D. So woo, jumping over here. And then D goes to B. And then B goes to C. C then goes back to, actually that's it, that's the end. So this is one path that you can do. I would suggest if you want to, you can even do like all your points in a circle, in a rectangle, however you want to start it. But another way of doing this is something that looks like this. All right, to have an Euler circuit, you must be able to travel in and out of each vertex. A graph of this vertex will be okay because you're able to travel in and out. A graph of this vertex would not be okay. And then looking at the Euler circuit theorem, a graph is connected to every vertex is even. So even degrees in any odd vertex, then it does not have an Euler circuit. So no odd vertex. Euler's path has exactly 2 odd vertex, no more than 2. And then if it has more than 2 odd vertex, then it does not have a path. All right, determine if the graph has a circuit, path, or neither, and explain why. So pause the video and try 1, 2, 3, 4, 5, 6. All right, let's take a look at the answers here. All right, you guys. So now what I'm gonna have you guys do is you're gonna create your own adjacency matrix, which is what we talked about for week 14. And we did this on Monday and Tuesday. So with this, what I want you guys to do is on a post-it paper, you're gonna be creating your own vertex. Use any letters. You need to have at least 8 or more letters. So I'm just do A, B, C, D, E, F, G, H. Then what size matrix is it going to be? Well, given the fact that we're 8, it's going to be an 8 by 8 matrix. List your edges among the 8 letters. So I'm just going to put edges, okay? And there are certain criteria. So I'm going to put AB, AC, BC, CD, CF, GH, EH, AH, and CH. And with your edges, I want there to be at least 20 edges. So you're gonna label your edges 20 times. Next, you're gonna include 2 loops. So my 2 loops in this case is going to be AA, GG, CC, okay? And then you also need to have 3 multi-edges, which means you're gonna go from AB, BA, I'm gonna have CF, so FC, So these are my multi-edges. And then CH, HC. So I'm circling my multi-edges. And then draw your diagram. Okay, so I'm gonna draw my diagram. I'm just gonna draw all of mine in a line, which is gonna be absolutely crazy. So A, B, C, D, E, F, G, H. There's my 8. Now that I have my vertex AB, so there's A, AC, here we go, BC, there we go, CD, here we go, CF, so C jumps over to F, CH or GH, so G connects to H, EH, so E then jumps over to H, AH, so A jumps over to H, CH one more time, so CH. Did I already do CH? Let's see, C and H. Here we go. And then I have AA, so A is gonna be a loop. GG, so G is gonna be a loop. And then CC, C is gonna be a loop. BA, so B goes back to A. So there you go. There is your multi-edge right here. FC, so F goes back to C. So here's your FC. Go. And then HC. So then H goes to C. There you go. There you go. So that is my diagram, which yours probably look a little bit better than mine. I'm just making it up as we go right now. And then fill in your adjacency matrix. So your adjacency matrix is going to be 8 by 8, which means you would need to have 8 across, 8 on the bottom. But because we're using an extra one, you want to make sure you draw it so it's like a 9 by 9. And I'll show you why it has to be a 9 by 9 in a second. And so looking at this one here, here is my 9 by 9 matrix. Okay, so here's your 9 by 9 matrix, okay? And looking at this part here, you want it to be 9 by 9 because you're gonna be writing down the letters here. So let me erase this piece here. And you're gonna have A, B, C, D, E, F, G, H. So you have to have that extra side right there and then fill in your adjacency matrix. And that concludes what you have to do for class today. All right, you guys, as always, I hope you have a wonderful week and I'll see you guys next time. Take care.